All right, so this is your quiz review. Again, I want you to have it open in front of you if you want to make any notes or whatever it is. The beginning stuff, it's 3-1, 3-2, and 3-3. Okay, the 3-1 stuff was talking about your periodic behavior, so the repetitive nature, right? So you could get asked to give the period from a graph. You could be asked to do something like this where you get the graph. All right, so then you, like if you got something like this, remember we took this and we identified the pattern of the period. So if I knew where my graph, you can pick how you want. This one, let's say I go from center. I have to go back to center, right? And then I want to duplicate that behavior. So if it starts at 0, you can just do the multiples of what's at the end. If it's shifted off, remember you also would have to alter it. So like if I went from here to here, the period is still 4 because it's from 1 to 5. But if I wanted to do multiples after that, where it ends is where it starts. So it's not like I can keep, this would be 5, 6, 7, 8, 9. Now I have to do 9. So I keep adding the period to whatever that first one is. The easiest thing is to start at 0, but you might not have that option. Like in that homework question, we didn't have that option, so we had to adjust it a little bit. And then you're going to answer questions based on that. So your increasing, decreasing behavior, your concave up, your concave down, your relative max, your relative min. Questions on those types of questions? Okay. Then came, these were from the same section, and these are your SOAR questions. Okay, so your arc length, your radius, and your angle. Remember that it's gonna give you 2 of the 3. So you'll get to use your calculators the whole time because it's not really gonna make a difference on the ones that are the graphing ones, and it will here. You need it. You'll get given 2 of those 3 things, and you'll solve for it. Okay. If it asks you to locate where theta is, okay, which quadrant, then remember we used the trick, which we did a little bit more yesterday. But this would be the evens are on the right. The odds are on the left, okay? And then in both directions, this is the halfway mark. So if it was 17.2 pi, it has to have pi in it. But if it was something like that, like literally 17.2 pi, then I would go odd, which is left, and then 0.2 is less than a half, so I know it's in the third quadrant. I would make sure you know how to do that stuff. And remember, if it doesn't have pi in it, you have to divide by pi to get it. So for example, if it said theta was 17.2, that is not with pi. I can't go straight into that trick, right? I have to divide that by pi. So let me get my calculator. So that I can write it in terms of pi, which would be 5.47 pi. And then that is still odd, so it goes left, and then 0.47 is less than half. That would still be in the third quadrant.
That's, you want to counterclockwise for that, right?
Because they're positive. Yep, if it was negative, I'd go the other direction. Yep.
If it's not in terms of pi and you have to divide it by pi, like, do you do that before you calculate?
I only do that to draw it. If it's just finding the angle, like here, just finding the measure of the angle, it doesn't have to be in terms of pi. Leave it alone. But if it said then locate where that angle is, now I have to divide by pi. Does that make sense? Okay. All right, second page was where we got into our circles when the radius was not 1. So these, remember, your sine is your y over your radius, your cosine is your x over your radius, and your tangent is your y over your x. Most of these images had the radius on it, like the 2 is there. You don't have to make a right triangle. If you did make a right triangle, then the Pythagorean theorem should still work, but you don't have to. And then 8 was what happens if my radius changes. If your radius changes, then you're doing r times the xy that is located at whatever coordinate point that is, and then I would distribute it in. And at this point, this is when we got into the unit circle. You would need to know all your over 6s, all your over 4s, all your over 3s, all that stuff, right? So if you don't know them yet, you've got 24 hours to make sure they're like ingrained in your brain. Every over 6 has a coordinate point. That's what? Root 3 over 2 and a half. Every over 4. Good. And every over 3. Good. And then what are the tangents at these locations? At the over 6, what's the tangent? Root 3 over 3. Takes 2 3s to make 6, right? At the over 4, 1, because they're both the same. And at the over 3, square root 3. And then I would say no top and bottom and right and left. So this is my tangent would be 0 and 0 and undefined and undefined. I think if you know that stuff and you know like your signs, your positive and negative, all students take calculus, or your XY combination in the first quadrant, both of them are positive. The second quadrant, the X is negative, the Y is positive, like that kind of stuff, then you should be okay. So if that was the case in questions like 8, A, and B, you're finding the X and Y coordinate at 2 pi over 3, and then you're multiplying by 5. And then at the end, number 9, this is where you're going to get given an X and Y coordinate, and it's going to ask you to find theta and the radius. So remember, the R is the square root of X squared plus Y squared, and we do tan theta equals Y over X. You're going to simplify your Y over X. It's going to be one of the 5 options for tangent. And then based on the original point, you pick the quadrant. So like this, I know I go back and up. I know that's going to be the tangent from the second, or the angle from the second quadrant. I always draw it just because that's like what my brain needs to see. But just make sure you know what quadrant it's in. Questions on any of the concepts? Yeah.
Is it possible to get more than one answer?
No, that's because that's technically if I just had this, right? Like if I just had an equation, which we're going to get into like solving trig equations. If it just said tan of theta equals root 3, there are 2 answers to that on my unit circle. But because you are given a coordinate point that gets you to that coordinate point is only in one quadrant. So you only pick the quadrant it's supposed to come from. Does that make sense? Okay.
Can you do one of those problems?
Sure, but let me give you different numbers so you can practice. All right, so negative 4 root 3 and negative 4. First of all, where is that? It's in my third quadrant, so now I'm going to pick from that, right? So then, do I need to do the radius or just the angle?
Just the angle.
Okay, so the tan of theta would be negative 4 over negative 4 square root 3. The negative 4's cancel, and this is 1 over root 3.
How do you know it's tangent? Because
It's always tangent because you're using y and x, opposite and adjacent. Right? Those coordinate points are your x and your y. So horizontal, vertical. The radius would be, if you involve sine or cosine, you need the radius. And you don't want to do that. Like you have the y and the x, use those. Okay, so then this becomes square root 3, I rationalize it, and it's square root 3 over 3. So where in my third quadrant is there an angle in which the tangent would be root 3 over 3? It's my over 6, and in the third quadrant it is 1 more, so it's 7 pi over 6. Okay, so maybe I would also like the 1 more, the 1 less, if you want to add that on to what you want to review. In the first quadrant it is pi, second quadrant 1 less, third quadrant 1 more, fourth quadrant 1 less than double. There's only 5 options for tangent. 0, root 3 over 3, 1, or undefined. The positive and negatives come into the 3 in the middle there, but other than that, it has to be one of those 5. You have to know that if it's a root 3 over 3, it's an over 6. If it's a root 3, it's an over 3. If it's a 1, it's an over 4. And then you have to figure out which the actual angle is based on which quadrant it is. So I know it's the over 6. I know it's in the third quadrant. And in the third quadrant where it's the numerator's 1 more, it would be the 7 pi over 6. Does that make sense? Okay. Yeah.
for the problem that you were just doing, like problems like those, you use tangent for those?
Always, because you have the y and the x, which is the opposite and the adjacent. Yep. Yeah.
Like, let's say one of the numbers was negative and not negative, and it fell into the quadrant. Would that, like, because tangent is positive in the third quadrant, if it was in another one, would it be
It has to align. Like if you graph it, like if you draw it out and it's a negative and a positive, I know I'm here, that tangent result is going to end up being negative. Yeah, it has to align. That like it won't be inconsistent. Is that what you mean? Okay. Any other questions? All right. This is also what will lead into sinusoidal functions, probably one of the more important sections, because not only can it be a question on your multiple choice, but it is guaranteed to be a question on your FRQ. So when we talked about, what was it, the fan blades, like we talked about the fan blades example the other day, it kind of expands upon that. So it's going to give you the information about what will be a sinusoidal pattern, and then you'll have to establish what that looks like, get the coordinate points, and answer questions based on that. So these two curves, sinusoidal means sine or cosine. The two curves that are the foundation of them are the sine curve and the cosine curve. The sine function is periodic, which means it repeats forever on end. Okay, it makes that wave shape. The most important thing to remember and the difference between them is the overall initial shape. So the parent function of a sine curve starts at 0, 0, goes up to the amplitude, back down to 0, down to the negative amplitude, and back up to it. We're going to talk about amplitude more in a little bit. But it gives the y-coordinate or the vertical displacement from your unit circle. So the overlap is if I had brought in my unit circle and I had just done the points from 0 to pi. Well, this is even just the quadrant angles all the way around. This is 1, 0. This is 0, 1. This is negative 1, 0. This is 0, negative 1. Now what it does is the sine curve takes the x-axis. Notice the x-axis are the angles. The angles are your input values. And the output is the y-coordinate from your initial thing, which is the sine. So at 0, because it all directly relates, right? At 0 on my unit circle, the y value is 0, which means sine would be 0. At pi over 2, which is the next marked angle on this graph, at pi over 2, which is at the top, what's the sine? 1, so it's up here. At pi, now on the left, what's the sine? 0, we're back to the x-axis. At 3 pi over 2, what's the sine? Negative 1. And then if I double back around to 2 pi, what's the y, which is the sine? It's 0. So that curve comes directly from your unit circle, okay? You need to understand the shape of it, and then we're going to get way more specific on the key points and that kind of stuff. The most important characteristics that you'll talk about again and again are the highest point and the lowest point, and the periodic, so the horizontal difference between where it starts and where it stops. The cosine curve relates to now the x-coordinates on those same angles. So if I went around my circle, and this is 1, 0, and this is 0, 1, and this is negative 1, 0, and this is 0, negative 1, and I put the angles on the x-axis, at 0, my cosine, which is the x, is 1. At pi over 2, it's 0. At pi, it's negative 1. At 3 pi, it's 0. And at 2 pi, it's back up to 1. So the cosine looks like a roller coaster. You would start at the top. You go down, and then you come back up again, okay? So sine starts in the middle, goes up, comes back down, goes back up again. Cosine starts at the top. The cosine kind of looks like a little sideways C, if that helps you remember it. And the sine looks like a sideways S, if that helps you remember it, okay? But one of the most important characteristics is the overall shape of it. Amplitude and period are the two things you're going to learn first, okay? The amplitude is half the distance between the max and the minimum values of the function. It is how high or low it goes off of your horizontal. So amplitude, how high or how low. On the parent function, your amplitude is 1. It goes up 1, God bless you, comes back down, goes back down 1. And the period is the horizontal distance of one complete cycle. This is what it would look like if it just continues to repeat. So if this is cosine, it would go down, it would come up again, it would go down, it would come up again, it would just continue to repeat. This is sine, up, down, okay? So 1 cycle is 1 period, and on the parent function, that period is 2 pi, because it's 1 full circle. Yep.
What is the amplitude on that?
Amplitude would be how high it goes and how low it goes. So it is, in this case, it's 1, because these are the parent functions, right? It's half the distance from the max and the min. So if you go top to bottom and divide by 2, that's your amplitude. Max minus min divided by 2 is your amplitude. If you look at your graph and you're on, if it's at 0, which is when it's the easiest to spot, it's how high up you go from 0, that's all. All right, so this one says the function value is given by f of theta equals sine. Describe the concavity and increasing, decreasing behavior on the given interval. So you have to be able to recall what the parent looks like and then answer these questions, okay? Because especially we're talking about concavity, increasing, decreasing. You want to know what it looks like, right? So we know sine starts at 0. At pi over 2, it goes up to 1. At pi, it comes back down to 0. At 3 pi over 2, it goes to -1. And then at 2 pi, it goes to 0. So pi looks, or sine looks like this. This is the parent function. So if I'm looking at just from 0 to pi over 2, what's true about the concavity? Good. Concave down because it's taking on that N shape. What's true about the increasing, decreasing behavior? What's happening to those y values? Getting bigger, getting smaller? Increasing. Good. Getting bigger. Then what's happening from 3 pi over 2 to 2 pi? Is that concave up or concave down? Concave up. And increasing or decreasing? Increasing. Easy stuff if you know what the graph looks like, right? So that's part of your challenge, is making sure you know what that parent function looks like. All right, we'll do one more and then we'll stop. So now we're basing it on cosine. So we need to know what the cosine parent function looks like. 0, pi over 2, pi, 3 pi over 2, 2 pi. It starts at 1. It comes down to 0, down to -1, up to 0, up to +1. So what would be true about the concavity from 0 to 2 pi? I'm sorry, from 0 to pi over 2. Concave down. And what would be true about your increasing, decreasing behavior? Decreasing. And then from 3 pi over 2 to 2 pi, concave up or concave down? Down again, increasing or decreasing? Increasing. Good so far? Yeah? Okay. So what I will do is I will open up the 3-4 homework tomorrow. If you want to start on it over the weekend so you have less to worry about on Monday, because on Monday I'd also love you to start your test review. The good news is after the quiz, it's really only one more section. So it's not a lot of content after that on your test. But I don't want you to get slammed with the test review and the full 3-4 homework for Monday.